Good afternoon. Good afternoon, all. Am I audible? Am I audible? Okay. So once again, good afternoon. This is the video lecture on design and analysis of algorithms. We are currently discussing with module 4, that is dynamic programming. So till now we have gone with so many concepts. So in that we come with our last topic. So last topic is reliability design. So till now we have seen transitive closure, Floyd's algorithm, Pioneer search tree, knapsack, Bellman Ford, traveling salesman. So in today's class we are going to discuss about new topic, that is reliability design. So come for the problem statement. So reliability design. So there are n devices di. Okay. So d1, d2, d3 up to dn. So n devices di, 1 less than, it is ranging from 1 to n. So d1, d2, d3 that we are representing from 1 to n using I. So it is connected in the series. So that is device 1, after that device 2, device 3 up to n devices. So if n devices di connected in series, then reliability of the whole system is given as G, reliability is given as Ri. So what is Ri? R is the reliability. So ranging from 1 to n, so G, I equals 1 to n Ri. Okay. So this is the reliability design. So for the entire n devices, so reliability design is given as I equals 1 to n Ri. So now you go with stage 1, stage 2, and so many stages. So multiple devices connected in parallel in each stage. So let Ra be the reliability of the device at stage I. If stage I has Mi devices, okay, if stage I, so I is nothing but stage 1, stage 2, stage 3 up to stage n. Okay, so if stage I has Mi devices, so stage 1 has how many devices? 3 devices. So that is, we are giving it as 3 devices of type I. So of type 1 in parallel, then reliability is given as chi I mi is equal to 1 minus 1 minus Ra mi. So if the stage I as if stage 1 as 3 m3, so d1 is m1, d1 is m1, d1 is m2, m3. So totally it is m3 devices of type 1. Then so the reliability of the design is chi I mi is equal to 1 minus 1 minus Ri to the power 1 minus Ri to the power mi. So come for the example part. So design a three-stage system with a device types A, B, C. Their cost are 30, 15, 20. So now you have to design three-stage system. Okay, so there are D1, D2, D3. So there are three-stage system with the device types A, B, C. So devices A, B, C, their cost is given 30, 15 and 20 and reliabilities are 0.9, 0.8 and 0.5 respectively. So, okay, budget available is 105. Design the system with highest reliability. So, when you now you have to design the system with highest reliability. So, that is devices A, B, C. The cost they have given 30, 15 and 20. So, 30, 15 and 20 and reliability 0.9, 0.8, 0.5. Okay, so maximum number of devices that can be purchased. So that given the budget 105. Okay, so example budget is equal to 105. So devices in parallel. Okay, so devices in parallel 1, 2, 3. Okay, so one A is having how much cost? So go for A's cost is 30, B 15, C 20. So A's cost you write, they have given how to find the reliability of the device. So they were going with reliability, they have given 0.9, 0.8, 0.5. So 0.9 you write cost, 0.8 with cost, 0.5 with cost. So this is one iteration. M1 equals number of devices 1. So M2 equals 1, M3 equals 1. Okay, now you come for number of devices in parallel 2. Okay, so reliability, what we are going when you are having 2. So 0.99, 0.9 plus 0.9 divided by 2. So that will give 0.99. So number of devices, if it is 1, now you are having 2. So cost goes 60. So now reliability, how to find the reliability? So using this formula, you can substitute this one. 1 minus 1 minus 0.8. So 1 minus 0.8 is 0.2. So 1 minus 0.2 is 0.96. So 15 plus 15, 30. Similarly, 0.5, you substitute here. So 20 plus 20 equals 40. So count for 3. So what is the cost of this one? A is 30. So now this we have find out. So come for this part, you are not having anything. So 30 plus 60, 90 is gone. So budget is 105. In that 90 is already gone. So you don't have much time to go with devices in parallel as 3. So now you come for the B. So what is the total cost? 30 plus 15, 45. So out of 45, 105. So next you can go with another 15, that is 45. So now 20 plus 40 equals 60. So SI, set of all tuples of the form. So Sij, I is the stage number, J is the number of devices. So S1 means one device of type A at stage 1. So S12 means two devices of type A at stage 2. Okay, so now you come for this particular thing. So this one you remember, S11 means one device of type A at stage 1. S12 means 1 means A only, 2 means B, C, 3 means C. So in that one, lower order 1, it is one device, lower order 2, it is two device. So count S11, that is 0.9 into 30, S12, 0.99 into 60. So S21, it is. So you understand carefully, S11 means, so 0.9 with 30, S12, this is 1, okay. So they come for S2. So S21, S21 is equal to 0.9 star 0.8. So 0.9 star 0.8 is equal to 0.75. Okay, so that's why given 0.9 plus 0.8 is equal to 0.72 with 30 plus 15 is equal to 45. So similarly, you have to go with yes 0.99 plus star 0.8, 0.99 with 0.8. Okay, so that gives, so 60 plus 15 is equal to 75. S22, so S22 you take it 0.9 with 0.96. So 0.9 with 0.96, comma 30 plus 30 is equal to 60. Next 0.99 star 0.96. So combining these two, so we can tell that this configuration will not leave adequate funds to complete the system. So further, same cost, retain the one with highest reliability. So yes, 1, 3, you have to find out. Combining all this, best reliability, you can take it as 0.648 with cost is equal to 100, where A 1 unit, B 1 unit, C 1 unit parallel. Okay, so this is the reliability design what we can understand this completely. So now you come for the assignment part. So in all these modules for writing internals and understanding the concepts, so you have to go with this particular thing. So first assignment, write the multi-stage graph using backward approach. Next, transitive closure of the directed graph using Warshall algorithm. Next, apply the bottom-up dynamic programming for the following instance, having the capacity of 10. So next, for the given graph, optimal cost store using dynamic programming, and then you have Floyd's algorithm. So this is up to module 4. So I will be submitting all these materials in the Google Classroom. Kindly go through the materials, write the assignments, and for the internals also. So this is up to, so this video is up to module 2, module 4, that is dynamic programming. So work on this particular thing, understand the concepts. Okay. So this is up to module 4, that is dynamic programming. So I will go through this particular videos in the YouTube channel 1DPMK. So kindly like, share, subscribe for the channel. Subscribe for the channel and understand the concepts very well. So in the next tomorrow's class, we shall go with module 5. Okay. So this is up to module 4. Kindly like, share, subscribe for the channel. Okay. So see you up in the next upcoming videos.